So, hello everyone, my name is Sumit Khitre. Today, under the subject Exploratory Data Analytics, we are going to see the topic optimization of loss function and best fit line using gradient descent. So, in the index part, we are going to see introduction to optimization, introduction to regression, loss cost function in regression, need for optimization, concept of gradient descent, working of gradient descent algorithm, learning rate, applications of gradient descent, and in the final one, we will see the conclusion. Okay. So the first one we will see introduction to optimization. Many of you have questioned that what is mean by optimization. So first we will see optimization. Optimization is a process of finding the best parameters or values that minimize the error in the code. In machine learning, optimization helps find model parameters that give the accurate predictions. Means in machine learning, optimization, what it does, it helps us to find the model or parameter that give the accurate predictions. For example, finding the best slope and intercept for the best fit line. Okay, as you can see in the diagram, we have drawn a slope with the best fit line that passes through maximum number of points that is scattered over the graph. So that is the optimization concept. Next, we will see what is meant by regression. So what is regression? Regression is nothing but it is a statistical method used to model the relationship between dependent and independent variables. Evaluation of a line means simple linear regression. That is y is equal to mx plus c. Many of you have seen this y is equal to mx plus c, that simple linear regression way before also. So where y define the predicted value, x define the input variable, and m means slope, that is that controls the steepness of that line. And c is the intercept where line cuts the y-axis, and the main goal of that regression is to find that best fit of all the data points. Means the line passing through the all the means maximum number of data points is said to be the best fit. Then next we will see the concept of loss function in regression. So what is mean by loss function in regression? Loss means basically the cost. Loss function measures how far the predicted values are from the actual values. Means it depicts and measures how the predicted values are far away from the actual values. Means common, and the commonly used loss function is mean squared error. For the loss function, we have to use the formula, that is L is equal to 1 by n summation yi minus y raised to i brackets square, where yi is the actual value, y raised to I is the predicted value. And objective of this loss cost function in regression is that is to minimize the loss function to find the best fit line. Previously, we have seen it, and it allows to minimize the loss function to find the best fit line for the optimization. Then now we will see what is the exact need of optimization. So there are multiple needs of optimization. The first one is to minimize errors, that is loss. Each prediction has some error that is caused in the form of y raised to I minus y raised to I, yi minus y raised to I. The next optimization reduce this error by fine tune parameters. These are the given parameters, and optimization help us to minimize those errors. So that is the first need of optimization. Then second need is to improve prediction accuracy. So to improve the prediction accuracy, a well-optimized model gives predictions which are very closer to the real values. The third one is to find the best fit line. As we have seen before, we have to find out the best fit line for optimization. So most and most probably need of optimization is to find the best fit line. That is among many possible lines, the lines which are passing through most of the points is considered as the best fit line. Best fit line. So optimization helps to locate the one which has a minimum loss. Okay, the best fit. The fourth one is to avoid overfitting and underfitting. Sometimes what happens, our line goes beyond the screen, or it becomes very smaller. So in such condition, optimization, what does it does, it avoid that overfitting and underfitting conditions, and it arrange the line in proper order. Proper optimization balances model complexity and also the accuracy. The fifth one is to achieve faster convergence. Efficient optimization methods speeds up learning and reduce the training time. Means whenever we use the optimization, then it speeds up our learning and it reduces the training time. Now, now we will see the concept of gradient descent. So what is meant by gradient descent? Gradient descent is an iterative optimization algorithm. It is an algorithm of optimization. What does it does exactly? It finds the parameter that is m means slope and c means intercept, that finds the minimum loss function. So the idea behind this gradient descent, that is move step by step in the direction of negative gradient, that is steeped descent. In the diagram I have shown uh, a graph, that is on the x-axis there is the weight, on the y-axis there is the cost, and the gradient is just moving towards the steep descent direction with the incremental step and initial weight. Now we will see the working of gradient descent algorithm. So the step one in the gradient descent algorithm step is that we have to initialize the random values of m, that is slope, and c means intercept. We have to take the random values. The step two is to predict the um, linear, that is y is equal to mx plus c. We have to predict the value of that equation. Then the third one is we have to compute the loss. So now how to calculate or compute the loss? So there is a formula for that, that is m is equal to m minus alpha delta l upon delta m, comma c is equal to c minus alpha delta l upon delta c. The next step is we have to update the parameters in the given compute loss. That is we have to use the loss function L is equal to 1 by n summation yi minus y raised to I bracket square, where alpha is the learning rate. And the next fifth step is that we have to repeat until we get the best fit line with the minimum loss. Now, in the previous slide, we have seen the learning rate. So now, in deeply, we will see what is mean by exactly the learning rate. So learning rate alpha is a parameter in gradient descent that controls the size of each update step taken towards minimizing the loss function. If we have to minimize the loss function, then in that case we will use the learning rate. What does it does exactly? It determines how fast or slow the algorithm learns. How our algorithm learns, it is determined by the learning rate. And how we can calculate the behavior of that alpha, that is the learning rate. If the learning rate is too much small, then it will give the slow convergence. If the learning rate is too much large, it overshoots or fails to convergence. And the third one is it choose an optimal learning rate for faster and stable learning. If you want a stable learning, then we can choose a optimal learning rate, extend it and a little bit if you want. Then now we will see what are the applications of gradient descent. So there are multiple applications of gradient descent. One by one we will see that. The first and foremost applications of gradient descent is linear regression. What does it does exactly? Find the best fit line by minimizing the mean square error. Previously we have seen mean square error, and now we use the linear regression to find the best fit line by minimizing the MSE. Okay. The next one is a logistic error. Logistic error is also the machine learning algorithm which we use. And what does it does exactly? It optimizes the parameters to classify data correctly. The third one is neural networks. Now, which is a deep learning model. What does it? It is used to update weights and biases during training. As you can see in the diagram here in the neural networks, there are three layers: input layers, hidden layers, and output layers, where the neural networks are connected with each other. And the fourth and last one is that is the support vector machines, that is the SVM. What does it do exactly? It helps in finding the optimal separate hyperplane. There are three planes in the diagram given below, and it is used for finding the optimal one. So that is the part. Now we will move towards the conclusion part. So what do we learn in the entire presentation? Now we will conclude it. Our first and foremost goal of regression is to find the best fit line that predicts the outcomes accurately. The loss cost functions that measures how far our predictions are from the actual values. Then gradient descent we have learned it is used to optimize this loss by adjusting model parameters. That is M means slope and C means intercept. And the last that we have learned is the learning, that is alpha, which controls the step size of each update, balancing the speed and the accuracy of our data. So that's it. Thank you.